Hello everyone. Today we're going to learn a little bit about how to calculate heat and energy. What is energy? Energy is the capacity to do work and or produce heat. Usually energy is only doing one of these two tasks at a time. Energy can be transferred between objects in the form of either heat or work. Energy is traditionally measured using the units of joules, which is its Système International unit. Other units for energy could include calories, where 1 calorie is equal to 4.184 joules. This is the most traditional of the units. Kilocalories, also known as calories with a capital C, which is the energy unit that is found on food nutrition labels, and electron volts, which is the energy per each single charge, aka the charge of an electron or proton. 1 electron volt is equal to 1.602 times 10 to the negative 19th joules. Energy is usually transferred between objects in the form of heat. It is important to note here that two objects generally will exchange their energy until they reach thermal equilibrium. That is to say, they will exchange heat, with heat going from the object with a higher heat flowing to the one with lower heat until they reach the same temperature. When heat is transferred, the process is described based on whether energy enters or leaves a system being an object or objects that you are focused on. For example, the system could be a particular reaction that you are looking at. If energy enters the system, aka if heat is gained by the system, this process is endothermic. If energy leaves the system, aka if heat is lost by the system, the process is exothermic. A large portion of spontaneous chemical reactions are exothermic, although not all of them are, just many. When heat enters a system, it can do generally one of two things. It can increase the average kinetic energy of the particles, causing them to, on average, move faster, or it can break apart interparticle forces, both the intermolecular forces or, in the case of some pieces of matter, the bonds that hold atoms or ions together. When the kinetic energy is changing, that means the temperature is changing, and heat can be calculated using the following equation. The heat, lowercase q, is equal to mc delta T, where m stands for mass in grams, as we are accustomed to seeing. C is a specific constant known as the specific heat capacity, whose units are joules per gram degree Celsius or joules per gram Kelvin. It is a measure of the amount of energy required to increase the temperature of 1 gram of a substance by 1 degree Celsius or 1 Kelvin. This difference is the same for Celsius and Kelvin conveniently. A specific heat capacity will be unique to each substance and also to each state of that substance. For example, the specific heat of water and the specific heat of ice are not the same. The delta T component stands for change in temperature. You are likely used to seeing this delta meaning change. Specifically, if you want to find this calculation, it is the final temperature minus the initial temperature. When the forces are being broken between particles, what's most likely happening is there is a phase change that is occurring. So, in this case, the formula that we would use is the one shown here. Q equals m delta H of a phase change, where Q and m are heat and mass, respectively, as we saw in the previous equation. However, the delta HPC, known as the heat or enthalpy of a phase change, is a new variable. It is the amount of energy required to make a phase change occur for a given substance. The subscript here of PC for phase change is usually substituted for something that represents the respective phase change that you are dealing with. For example, a heat of fusion, abbreviated as FUS, is used when dealing with melting or freezing. A heat of vaporization, abbreviated VAP, is used when you're dealing with condensation or vaporization, and a heat of sublimation, abbreviated SUV, is used for sublimation and deposition. Notice, for the previous equation, you could get a negative answer. For this one, there is nothing specifically in the setup that would allow for a negative answer. Yet, several of these phase changes, the freezing, the condensation, and the deposition, are all exothermic. They will result in energy being lost, and therefore the heat should be Q for those. The Q should be negative for those. The units for the heat of phase change are generally joules per gram. You may also see a version of this that has a molar heat of a phase change, where it'll be joules per mole, and in that case, you would want to multiply it by moles rather than mass.